The video ended on this problem. We're at the bottom of page 3, lesson 3, module 6. We had just solved the equation for y, and we were getting ready to write the important bits of information. So what's in front of the x, remember, is the slope. So the slope is rise 3, run 5. And the y-intercept is 0, comma, because y-intercept always says x0, and then we pull that number down. So what do you notice about the next two? Notice something different? Only an x, only a y. You have to be on the lookout for those. Super important. They just keep popping up. They're on the final. They're on the next test. They're on the next test. So the minute you see something that looks odd, like these, here, this one has an x and a y. This one has x and y. This one does. But once you see these with only a single variable in your head, you should go, oh, these are the horizontal and vertical lines. And remember how I said with the special cases, once you realize they're horizontal and vertical, it's easiest to first just graph them. And then you can read the information right from the graph. So this first one says that x is 4. That means we're only going through the x-axis and we're going through at 4. So 1, 2, 3, 4. So that would look like this line, because the variable that's listed is the axis that the line passes through. So notice it never touches the y-axis. It passes through the x-axis at 4. And make sure you don't draw a dot on that. It's not a point. If it was a point, I'd call it 4, 0. X equals 4 is the equation of a line. So it's a line through 4 on the x-axis. So now that we have that drawn, now we can read the information from it. Is there any skiing on this? Oh, no skiing. That's a vertical line. I cannot ski on that. So I write m equals undefined. And the other question I wanted you to answer was the y-intercept. Does it ever cross a y-axis? Does that pink line ever cross it? No. So you remember what we wrote for that? We wrote none. So slope, undefined, because there's no skiing. Y-intercept never crosses the y-axis. Okay, on the next one, y equals -3. Let's draw the graph right here. So on the special cases, like I said, the graph gives you all the answers. So I always, whenever it's a horizontal or vertical line, put a rough little sketch, and then I can read the answers from that. So y equals -3 tells me it goes through the y-axis at -3. So it would be this line, which you can see is horizontal if it only passes through the y and never goes through the x. And at -3, so here's the y-axis, goes through at -3. So what do you remember from a couple pages ago? Can I ski on this? Yeah, but it's 0 fun. So we can see our slope is 0. And where does it cross the y-axis? It crosses the y-axis and has a y-intercept of 0, -3. So 0, -3 is where it crosses the y-axis. And last but not least, we have one here that is not solved for y at all. So we have to do all the work, and then we can read the information from it. So if I need to get y alone, does everybody agree I would need to first subtract 4x? Because this is a positive 4x, so I do the opposite, subtract 4x, and it's gone. And it might be helpful. Do you remember when we learned that -y means -1y? Because there's going to be another step after this, and it's kind of nice to have that in there. Then on this type, remember how we said to switch the order so that we can make it look like y equals mx plus b? So first we put our negative 4x, and you always carry the sign that's in front of it with it. 2 doesn't have a sign, so that means it's positive 2. Still don't have y alone, and in order to read the slope and y-intercept, y needs to be totally isolated, so I do the opposite, and that's why I put that negative 1 there to remind me. So the opposite of multiplying by negative 1 is dividing every single term by negative 1. So then 2 negatives positive, 2 negatives positive, so I get 1y, or y equals positive 4x. 1 negative is negative. So now I have everything there I need. So my slope is 4, coefficient of x, and my y-intercept written as a point. X is 0, y is, and do you remember how we said on this one earlier, let me slide the paper over a little bit, that you have to take the sign with it, so b is negative 2. So my slope is 4 and my y-intercept is 0, negative 2. And you'll see that is such an important skill when we go to graphing lines without t-tables. So solving for y, huge. Then being able to identify the important parts, also very big. Okay, so let's start on the last page for today's lesson, which is page 4. My videos got a little bit longer than 9 videos. This cutting off at 15 minutes is kind of driving me crazy, but that's the camera I bought. So let's go ahead, and this is the beginning of what we do the rest of this class is functions. So before we start functions, we need to discuss some vocabulary. So a relation is a set of ordered pairs. So let's put a set up here. Let's see, let's write 0, 1, negative 1, 3, 4, 5, and 0, 7, let's say. So just any random set there. So ordered pairs are points. So I have 4 points there, and I have them in set symbols because a relation is a set. So this would be a relation. The domain of that set of ordered pairs is all the x values. So the domain is the set of x values. And they're also called input values. So let's look at this set and go over here to the side. What would the domain of that set be? What are the x values? 0, negative 1, 4, and I don't name things twice. I already said 0. So this is what the domain would look like. 0, negative 1, 4. And notice it is also a set, hence the answer needs to be in set symbols. So the set of x values. So the first x is 0, the second x is negative 1, the third x is 4, and I already named that x, so I never name it twice. So that is the set of x values, or the domain of that relation. The range, you can probably guess, are the set of y values. And as you can probably guess, those are called the output values. And the reason they get these names is because we input x, type it in our calculator, and the answer is going to be our y, and that's why it's called the output. So looking at the set, above, what would the range be? Let's do it in a different color. 1, 3, 5, 7. So the range are all the y values. None of them are repeated, so I have to list all of them. 1, 3, 5, and 7. So that would be the range of this relation. So then what our task is in this module is to decide, is that relation a function? Well, in order to decide that, you first have to know what the definition of a function is. So it's a relation where each x value or input is assigned exactly one y value. That is something you're going to have to repeat verbatim on the test. They say what? Define a function or tell why the following is a function or is not. And you'll see when we get down here, is this a relation, why or why not? We're going to refer back up to that definition. So that's one that you do need to memorize, but I think by writing it 2 or 3 times on this page, you'll probably have it memorized after that. Of course, you'll have to look back at it before the test, but it should be pretty well ingrained by the time we're done with the functions. So a relation means it's a set of ordered pairs, but each x can only have one y value. So let's look up at our relation above. Is it a function? This x0 has 1, negative 1's assigned to 3, 4 is assigned to 5. Oh, now we have 0 assigned to 7. So see the x value 0? It's assigned 2 different y values. So this is not a function. So let's write that up here. The above relation is not a function because the x value 0 is assigned 2 different y values. So 0 is assigned 1 and 0 is assigned 7. And according to this definition, in order to be a function, each x value is assigned exactly one y value. So if you see an x assigned to 2 different y's, then you know it is not a function. So the above relation, let's draw an arrow up here so we know what we're talking about. So the above relation is not a function because the x value 0 is assigned 1 and 7. So 2 different y values. Okay, let's practice. So example 1. And I'll give you a little heads up. This is your x, this is your y. So activity is x, calories burned is y. So anytime they make a t-table, the x values will always be on the left, the y's on the right. So they might not call them x and y, but you can assume that anytime it's in t-table format that the x's will be on the left. So the domain we'll talk about in the next video.